The first one is to make sure the code you write is actually efficient. Avoid the for loop, so vectorize what you can. There are also certain packages that can help, that are really efficient, like data.table is really efficient at doing operations on big tables. You should profile your code to find out where you have bottlenecks so that you spend your time optimizing the right parts of the code. You might be surprised what is actually taking a long time. It might not be what you think. And of course we can rewrite the parts that are really time critical in C or C++ and just link it in. It's really convenient to do with our CPP package. That's the first category. The second category is we need to make sure we leverage the multi-core capabilities that we have now. Even on our laptops, we can run at least 4, often 8 processes in parallel without any benefit or penalty. And some of the packages leverage this. So R in itself is single-threaded by default, but that's true for most programming languages, to be honest. But there are some packages that help us overcome this. We have parallel for each and do parallel. For instance, I use mclapply a lot, which is the multi-core version of lapply. It's really, really convenient and it's easy to swap between those two. Some packages leverage this out of the box, like Ranger, which is a random forest implementation, uses all cores to grow the trees, which is great, which the default one, a random forest, doesn't do. Packages like Caret can run things in parallel with regards to cross-validation, that sort of thing, to really leverage that. There are also things you can use to do things asynchronously, like in the Shiny app, to do things in the background while serving other users, that sort of thing. So we can do those things to leverage multi-cores on our laptops, but of course especially interesting on a cloud machine where we can easily have 96 CPUs or things like that. So we can really get benefit from this. The next level is to scale with multiple instances of R, and this is really what ThoughtWorks did. They had many instances running, and this is also what we do when we specify replicas 2 or replicas 10 or replicas 100 in Kubernetes. It will spin up many R instances, and that enables a lot of throughput in that. And you can actually get automatic scaling from Kubernetes as well, so you specify the maximum and it will scale up as many as it needs depending on the load of the system. And you can scale also on the node level, so it actually creates new machines, new virtual machines, and adds them to the cluster. I did that for a client earlier, it was actually last year, where we had a cluster that was only one machine when there was no load. But when we ran a big process, we had 18 machines processing that load, and it was completely automatic and all with R code as well. So the throughput was fabulous. And finally, you can use the MapReduce paradigm, which was what ThoughtWorks used, where they divided up the work in pieces and combined them at the end. And of course, we also can have backends like Apache Spark and H2O that implement functionality in different languages with different technologies, but we can still do all our data prep and all our analysis and visualizations in R. We just work with a different technology on the back end. And if the APIs are good, we don't even notice. So there are a lot of things we can actually do to make this better. And so I urge you to think and work with this if you are in this position that people think, oh, it might be too slow, etc., etc. It's not exactly true. You can make it work in most cases. So I'm nearing the end. I just want to highlight a few resources. I wrote last year a tutorial deploying Shiny apps on IBM Cloud. That's something you can try if you want to get hands-on experience. You can do it with that tutorial. You can do it with a completely free cluster on IBM Cloud. You don't have to pay a cent for that, and you can deploy your Shiny app on that using the Kubernetes service and the container registry, that sort of thing. I also have all the sample code that you have seen today on my GitHub account there. Here's the link to IBM Cloud if you want to register. There's a free tier, so you can register and do actually a lot of stuff without paying for the platform, especially when you're trying things out. So I really recommend you trying that. Some interesting articles. RStudio has written a really cool set of tools related to load testing of Shiny. So you can record a session where a person is using Shiny, and then you can play that back hundreds of users at the same time and see how it performs and how it scales. Joe Cheng's talk, I'm not sure if the recording is available, but the slides are there, so you should check them out if you're interested in running Shiny in production. And finally, a really good kind of easy introduction to Docker for our users, written by Colin Fay, an absolute fantastic person. So, going back to our question, can we deploy? Yes, we can deploy our code. That is my clear message, so I wrote it in really big letters. So if you want to take anything away from here, yes, we can. It's actually fairly easy to do it. I could show in just a few slides how we can do that. It's secure if we leverage the functionalities that is in the platform, that is Kubernetes, that is in the cloud. And it's also scalable. We can easily scale multiple instances, that sort of thing. So that's the kind of message I want to convey to you. So hope you agree to that. Thank you very much.